Okay, so we will be talking about uh, quantum mechanics, and in quantum mechanics, we'll be talking about interesting topic, which is Compton effect. Okay, because this effect occurs in such a way that if this effect, if it didn't occur, we could have we could have another effect which is known as which is known as as photoelectric effect. Okay, photoelectric. Oh wait, what? Photoelectric effect. Okay. Now we all are familiar with photoelectric effect that when I think you can wait. Let me change the color. So when we have a particle, let's suppose not particle, photon, and this photon is moving towards this photon is moving towards a electron. Okay, and the moment it hits this electron, and if it's in a surface, okay, what will happen is it bounces off and it will escape. Okay, it escaped that surface. So this is now it's just escaped electron. Depending on the energy of the photon, if it's more or equal to, or if it's more equal to or less than the energy of photon, so electron, we will have different observations. Observations. Okay. Now, and other than this photoelectric effect, it could also have another effect known as not effect. It's like rise in level. Rise in level. Okay. By rise in level, I mean if it has let's suppose if it's in this level of the atom, and the electron is coming to photon is coming towards it. The moment this photon absorbs this electron absorbs the photon, absorb. Okay, what will happen is this electron may rise in level. Let's suppose it went from this one to this level. It got excited. That's what we call it. It got excited. Got excitation. Excitation. Okay, and it's in ground. This is the lowest is known as ground state. Okay, and then the principle number one and two, three, and like so on, 1, 2, and 3. Okay, assumptions, and uh, and then coming towards our main topic, which is Compton effect. What Compton effect is that in uh, there's a photon e EP. Okay. Now, in Compton effect, what we observe is if the photon is coming towards the electron here and it collides with the electron, we have talked about the scenarios above as well, but here the Compton effect is special. How it's special is that in Compton effect, there could be a scenario in which photon will reflect off of the electron. Okay, it will reflect off of the electron, reflect off of at any angle. Okay, and the angle between the reflection and the electron is known as theta, or sorry, phi, and even electron can also reflect off, and this is known as theta. So what we are observing is that, wait, sorry, photons coming in, and the moment it hits the electron, instead of it electron absorbing it or electron absorbing it, what happens actually is it gets reflected off. Okay, now if we talk about, wait, let me label this label let me do labeling let me do the labeling. Angle of electron leaving, and this one is angle of photon leaving or reflecting. Leaving mean current area. Now now then what else we have here is that we can actually calculate this, whatever is happening over here, we can actually calculate it. And to calculate this, we have certain, wait, let me just copy that diagram. uh, this one over here, it will work. Yeah, copy. So we can actually calculate the scenarios. What's happening here actually is, what's actually is happening is, we have this photons, we have the wavelength of this photon, and we have the wavelength of this photon. Photon is the same. This photon is the same as this photon. The difference is only that this is not scattered photon, unscattered photon, unscattered photon, and this one is scattered photon, scattered photon. Okay, and so we can write the equation as scattered photon is equals to not scattered photon plus, this is me writing equation of how it will work, or like how it's done actually, the mathematics behind this Compton effect. The wavelength of the not scattered photon is equal to wavelength of the scattered photon. I'll tell you why why I took them as different value, as they are different values. Okay, they're not the same values. Plus, what the point of it, with the particle it got hit with, that the properties of that particle, which is h, which is nothing but Planck's constant, over mass of that rest particle, in our case it's an electron, and c, speed of light. So, and one more thing is 1 minus phi. Cos phi is this, the reflection or the angle between the electron and the scattered photon. This is our equation. Okay, now here you might have noticed, if we're talking about electron in our scenario, electron and photon, this is a fixed value, as they all are constants, as they all are constants, right? So what value do we get if we calculate this, because we'll get this out of our way, so we don't have to work with this h over m mass rest of c again and again. We don't have to write it, so we'll just get the value and we will finish this off at once for this one. So if we apply copy and we'll get this value somewhere over here. Yeah, perfect. Compton this cos phi can have values between 1 and cos 1 and
Current
sorry
page 416.
minus 1 and
417 pages.
1. Okay, 1 and minus 1. And since we're talking about only cos phi, not 1 minus cos phi, but when we include 1 minus cos phi, it becomes 0 and between 0, more than 0 and less than 2. This is the values we will be working with. Not we will be working with, this is what it actually is for 1 minus cos phi. And so then, and I can even give this special name. This Compton wavelength is nothing but Compton wavelength of electron. But this E, I mean electron. But if I want to put as if I want to put this for over here at the top, h over m0 c, it can be written as wavelength Compton. This will depend on the particle which we are working with, which is the just changing particle over here. Even we can get the Compton effect of Compton wavelength of photon as well. Okay, now we can, then there's something more about uh, the energy and the momentum. Yeah, there's one more thing. Momentum is also part of this concept, that if the particle has energy, it must have in momentum. Okay, so and regarding that, then we get an equation which is known as electrons energy is equals to, we're talking about energy is of electron actually, c square root of p e square plus m e c square. Okay, this is what we get as our energy of energy and momentum relationship in this electron scenario. So then if we talk about, yeah, so yeah, that's it over here. Then this is just equation which you should remember, not remember, it's like this general information. And then after that, one more thing is that when we talk about the angles at which it happens, let's suppose if we have scenarios, different scenarios at zero angle, at 90-degree angle, okay, at 90-degree angle, then at 180-degree angle. We can have many other angles as well, but these are the main angles we're talking about. Now, if we have the scenario being done in 90-degree angle, sorry, 0-degree angle, there's a photon coming towards the electron, and by 90-degree angle, 0-degree angle, there must be no change, so it must go like this, right? So let's check what will be its what will we have as what we're talking about, which is what we're trying to get is a wavelength, right? So the wavelength which we will have is lambda is equal to lambda scattered plus, we have this value, right, h over m 0 c, which is 0.0024 nanometer, 0.0024 nanometer, plus uh plus what, 1 minus 1 minus cos this. So now this over here is actually, let's suppose if our scattered wavelength is, if I take an imagine 0.005, okay, nanometer. I'm just supposing we will be using it all in all of them. So what will be our answer is 0.005 nanometer plus 0.0024 nanometer, and yeah, that's it. So it will be different in every case, and depending on whatever we have, it will change. And yeah, that's it. It will be the same for all others. We just have to put in the value which we have over here. Thank you.